services that are out there and have a look at how they've changed. It's going to be a bit of a chalk talk type environment, so you've got a question, you've got anything you need to know about, you stick up your hand, you just ask, you interrupt. Some of the stuff you will have dealt with, some of the stuff is relatively new. And the reason we're doing some of these talks is a lot of our customers are out there and they put the network in place maybe 4 or 5 years ago. So it's suited them well up until now. But the landscape has changed quite significantly. And you can get away with a lot more for a lot less with some of the newer technologies that are out there. So it's often worth going back across your architectures and reevaluating some of this, because what you may have been really good and easy to do 3 years ago, now there's a more managed service type of way of doing it and operating. So I'll look at this in three tiers. We'll look at the host-based protections, we'll look at internetworking between various network constructs, and then we'll look at edge protection. And the final piece, we'll talk about bastions, which is often a vulnerable point for customers. So my name is Sidney Sigournay. I work with AWS Pro Services. So we do exactly what AC3 do. We help customers achieve and do infrastructure in the cloud, help them with migrations and all that kind of good stuff. And the reasons the networking has changed quite so significantly in the last 5 years with AWS and new features is because our customers' worlds are complex. One size definitely does not fit all. So you would have found that what you had to do 3 years ago to meet your requirements was often quite complex. As a result is that we have what is called generations of code. The first generation builds it and they just get it running. The second generation are happy to maybe support it, and then by the time it gets to the third generation, they're just praying nothing's going to break because the level of complexity they may not be fully cognizant of and able to make changes. So a lot of the challenges that people face, we take back as feedback and we start developing services to make it in a more managed way so that you do not have to spend a lot of time with very bespoke solutions to meet your ends. So at first level that I'll start talking about, and again, interrupt me at any time if there's any questions or you have any statements to make, that's all good. Protecting network and host level boundaries. So this is your lovely server that you got out there in the cloud doing whatever it is that it does, and how you're going to protect it on the local VPC level. And you'll all be familiar that when we brought out VPCs, it was quite a radical change. Before that, your servers just sat out on the World Wide Web and they had a security group wrapped around them, and you prayed that nothing bad happened to them and you kept patching good, and that nobody poked too many holes in your security group they didn't know about. Then we introduced VPCs that allowed private IP address ranges, multiple subnets, and that meant that your boxes no longer had to all carry a public IP address. And if you find yourself in a... What's up? Must I talk louder? Sorry. I will shout. If anybody can't hear me, just put your hand up.
Try the mic as well, but I'm not sure it's ready.
Hello? Hello? We're having a big technology fail today. No, no? Well, no, I'll just keep yelling.
I know you can.
I'll just keep yelling. So back to VPCs, and that was quite a revolutionary change because that meant you could slice yourself your own little piece of networking out inside AWS, and then all your devices and servers no longer had to carry out public IP addresses. And if you find yourself in a place where you are putting servers out with, again, public IP addresses, that's something that should be reconsidered because at the end of the day, servers with operating systems that are managed by people, well, let's just say they have a lot of vulnerabilities, and not a month or two goes by without another vulnerability being exposed, and then people realize they can get compromised. So by protecting these things deep inside your VPCs, you have that advantage of before your operating system is ever called into compromise, they have to be able to get there. If you can't reach it, you can't hack it. So the VPC is being very important, and there's plenty of options out there on how to build your standard 3-tier VPC and keep your databases safe from your application servers, safe from your web front ends that are there. We then introduced things like Private Link, which meant each VPC, before Private Link came along, in order for you to talk to the control plane on any of the AWS APIs, you had to have an internet gateway. You had to actually be able to talk to that internet gateway. So one of the first things that a lot of people would remember, they'd end up building NAT boxes themselves to be able to translate from the private networks to the public networks, so that they could control and manage their applications. So that things like IAM policies and that, you'll be able to really get their secure tokens and all this kind of stuff. So, yep.
So, is there something like the Express route, so it's like a link between your on-premise to the cloud, or?
Oh yes, definitely. So,
Is
we
it a dedicated one, or is it a VPN?
yeah, so you can do both. So we call it Direct Connect, and that means, but it gets quite expensive. It can go from 1 gig. You could buy sub-gigabit speeds from partners. So if you didn't need that, or you can go 1 gig, 10 gig, 100 gig, a dedicated dark fiber to the cloud. That means you've got a steady guaranteed bandwidth. 10 gig and 100 gig is now encrypted on the wire, whereas anything less than that is not, but it is a dedicated private connection. You could also do the same thing with VPNs and be able to throw some VPNs straight into your VPC and connect it. We've now launched something, VPN Accelerator, which means that because we've got an edge location in New Zealand, the problem with VPNs is it's the ebbs and flows of the internet. So if your service provider is providing a crappy service one day, or they just oversubscribe, your VPN is going to suffer because of it. With the edge locations now being in New Zealand, that means that you only have to worry about the connectivity to the nearest POP, and then it goes across our backbone in there. You pay a bit extra for that, but it does give you the reliability if you didn't want something like Direct Connect, or Direct Connect via another partner.
Where is the edge? Is it in Auckland?
I can't discuss. There are 2 of them. North and South Islands are covered. The exact locations are usually kept quite right. I honestly don't know either. So the way AWS works to keep all our accreditation, people who work inside the data centers never work with customers, and vice versa. So I've never been inside one of the data centers because I can't, because I work with customers. So what we used to have in the Sydney office, used to have this big fish tank, which was full of mobile phones. People who made the mistake of walking into the data center with an electronic device, you're never getting it out of there. It gets squashed, crunched, thrown into a vat of, well, not a vat of acid, but if they could find it, they probably would, and hit it with a hammer. So again, all the disks that come out of the data centers and stuff, they get physically destroyed because it's part of the ISO 27001 and all the other accreditations that have to go into it. So they take that very seriously.
That'd be a fun job.
It would be. That's all your job, sitting there smashing things with a hammer. It's like, kind of not good, I guess. But it's a very serious business. So all the laptops that get taken into the data center never come out. All the switches never come out. They literally have to be destroyed in order to maintain that level of classification. So Direct Connect is definitely a good way of keeping your on-premises connected to the cloud. And Private Link, again, had another feature where if you were connected, your data center was connected to your VPC and you had Private Link, you could then access all the AWS services via those private links across Direct Connect. And that's a big concern for folks when they, for example, if on-premise you were busy talking to S3 and you were talking to one of your servers, the S3 connectivity would likely go across your ISP, whereas your connectivity to your server would travel across your VPN.
What is the difference between private link and secure gateway?
And
secure gateway.
Secure gateway. I'm not familiar
To
with that.
VPN connecting directly to Amazon.
Oh, okay, okay. So Private Link, it is TLS encrypted connection through to a service in the background. You could build your own service, but let's just say, for example, you wanted to talk to SNS. So what that would appear as is a local IP address in your VPC, a 10 dot whatever address would suddenly appear inside your VPC. The DNS would masquerade, instead of going to the public SNS topic, would then be pointing at that 10 address. So you'd have 3 network interfaces dropped in each availability zone if that's how you chose to build it, and then all your connectivity would hit that private address and then go across an encrypted tunnel. So all the communication is all HTTPS to most of our endpoints by default. You can do exceptions to HTTP on a few of them, but the private link itself is encrypted, and you can build your own services behind private link. So think if you had a database, for example, and you wanted to advertise it to 3 different VPCs. So in the past, what you'd have to do is pretty much set up a link between the 2 VPCs. You could do that via VPN if you really wanted to. You could just use the interconnects between the VPCs, or you could use Transit Gateway. It will get really complicated. But what you could now do is build your own private link service so that you could connect to 1,000 different VPCs, and all the servers it would appear as if they were connecting to a local endpoint inside their own VPC. And it is one-way originated traffic, so it becomes a very secure way to share a service out to an entire organization if you needed to, 1,000 VPCs if you wanted to. So the private link is a very prominent service, and it's worth looking at if you need to distribute certain services across multiple VPCs and you didn't want to go all the way down the road of maybe a transit gateway or maybe a peering connection. It becomes really, really good way to do that. Because effectively the private link sits in front of the network load balancers, and it has a group of servers behind it. And that group of servers is obviously kept healthy and it auto-expands, and it's all invisible to your local networks. And you could then do a private link to one of your customers if you wanted to, and advertise the service across. So things like financial feeds and stuff like that within AWS can be shared between customers. And it means that you then have a very secure way of talking without having to go across the public internet to expose a service. So it really reduces the attack surface that's available. We then introduced. Oh, yeah, go for it.
S3 transfer acceleration goes through private link?
No, so transfer acceleration, that goes through our edge networks.
Okay.
So our edge networks, what it basically means is if you try to transfer accelerator, instead of actually going to the regional edge for S3, it will find the nearest POP, and then, which means that there's more guaranteed bandwidth. Mm-hmm. So let's say you were in the US, and you were a couple of states away from the region you're trying to hit, but there was an edge location close to you. That means you'd have guaranteed bandwidth, and you'd only be transferring over the public internet till you hit that POP, and then you'd be able to just dump it straight across the back. It does cost extra, but it's for certain use cases it does pay for itself just for the speed at which it does it. Edge technology has become more and more important because we can't fix that speed of light problem, and it's more things are moving to the edge because the demand's getting out there. So you would have seen us introduce services like wavelength and stuff like that, where we're actually moving edge locations into telecom POPs, like at the edge of the motorways and stuff like that, because the bandwidth requirements for things like self-driving cars are just going to be ridiculous.
Local.
Yeah, they try to keep it local as possible. Yeah, so it becomes an interesting subject. We then introduced flow logs, which was a good way to do flow control inside your VPCs. You could now what a flow is different than a packet capture because it is a summarization of a particular network flow. And when you turn on flow logs, you can suddenly get a very good picture of how traffic is flowing within your VPC. This links onto other services like things like GuardDuty, which uses machine learning, and it can figure, I know what normal looks like after 30 days, I know what the connectivity is. You suddenly pop a box up and start doing a port scan of another box, and all alarm bells start going off because it is an unusual traffic. It's unusual traffic that has occurred. You try to do things like DNS exfiltration, same problem. It suddenly GuardDuty kicks off. So the flow logs, you can actually use them for your own uses yourself. Keep it as a good recording. You can pump them into analytics tools and be able to get a really good idea. There's some good patterns out there for folks that did monitoring of security groups and be able to audit how permissive security groups are by just capturing flow logs, putting them into Kinesis, and then being able to pump them into the favorite analytics tool and just draw pretty graphs on how the traffic's flowing. There's easier ways to do that nowadays, but it gives you a lot of potential to be able to detect where these flows are and what are good flows, what are bad flows. The NAT gateways, when we introduced that made a lot of difference because before that you would have to self-roll your NAT gateway, and there's plenty of architectures on there how to keep these things auto-scaling and keep them always available, because when your NAT gateway went down, a lot of communication would have just stopped. You still had to feed and water these damn things, and you had to patch them, and they carried a public IP address, so that itself was a problem, which meant they were an attack surface. We introduced NAT gateways, took a lot of that away. Quite scalable feature that you would place into each availability zone, and that we'd secure them and manage that service and ensure that they were patched. The original security construct was the VPC security group, that was a state, I use the term, it is generally a stateful firewall service that is available that can wrap a single network interface. You can have up to 5 of them on a single network interface, and it's basically you tell it what patterns are allowed. So as soon as you, because in its entirety it becomes a stateful firewall, it can track a connection, so you just tell it which ports it can talk to and which targets it can talk to, and it will maintain the reverse connection and allow you to actually build up that service. When I say it is usually stateful, the default configuration of a security group is egress permissive. And in that case, it is stateless. There's no point in tracking a session if you're allowing everything outbound. And the reason that becomes important, because as soon as it switches from being stateless to stateful, it will actually drop all the sessions. So you learn that the hard way when suddenly you add an egress rule and suddenly all the TCP connections go. And then they have to start building up these tables. But the reason we actually do that is because just there's no point in maintaining state on something that is always permissive. And we would just probably use up the world's switching memory just to try and maintain these things for no added value. So after that, the security groups came the network ACLs. An underrated service, not many people use it because it is a stateless firewall. And the major difference between stateful and stateless is the speed at which you can process packets. So stateless takes a lot less CPU power than doing a stateful rule, because you don't have to look up anything. You just look, matches pattern, doesn't match pattern, throw it away or keep it. So because it's stateless, you have to then say, I want to speak to port 80 on this particular IP address target, and I'm also willing to accept back all the ephemeral ports on the way back. So that when the TCP session is set up, it will make a high range port connection on the way back, and you've got to allow it. So the general rule of thumb that a lot of people follow is security groups fall into the application tier. They create these things, they maintain it. And the NACLs fall into whoever's looking after your network, and you don't let the application teams near it. So the rules are much more, are not very fine-grained, they're quite general, but they're also the hard limits as to what communications you would actually like to enforce in your network. And it's typically the same people who can modify the security groups don't necessarily have access to the networking, because they just break it. And you don't want them to do that, or make it overly permissive, because it keeps people awake at night. Sorry, this is just was a duplicate of that one. And I probably should have flipped through slides while I was talking about it. And we go into our favorite security groups as we were talking about, level 3, level 4 stateful security groups. Very similar to the host-based firewalls that you might have. And don't discount a host-based firewall, they are also quite important. And the thing about network security is you should always have a layered approach. The more layers you have, the safer you can sleep at night. If you're just relying on a security group, you should be worried. People may make a mistake and it's got to fall back to something. So the host-based firewall is actually quite a decent, you can control them if it was Windows through group policies and stuff like that. It's a different chain of authority that is needed to make modifications to it, and it shouldn't be discounted. And if you can work it into your system, part of your security repertoire, it can pay for itself. Yep.
Yeah, I think that's right. But I think, like I found in when I work, is that the firewall on the server a lot of the time is making my job very hard, like a networking guy, because you troubleshoot it a lot.
Yeah.
And the guy that, like the developer or whoever is like the maintainer of the server is complaining, I see nothing. And then you go, and I was like, what is the problem? And you start looking at his machine, and he's enabled the firewall and stuff. I think you're right, but maybe if there's like a very good
troubleshooting.
Sorry?
Very good troubleshooting
on
that. So there are options. The flow logs are your friend out of the VPC, because you can tell if it's dropped by a security group or dropped by NACL. And if it got all the way to the server and it never came back, well, then it's like you're pointing at something on the server. We also did something called VPC Reachability Analyzer, and that just launched possibly 2 or 3 months ago. It's really cool because you could literally say from this point on my VPC to that point on the VPC, follow the path through, and it'll tell you every NACL security group that it's heading on the way through, and whether it was accepted or dropped by our network or dropped by the box. Now, we have other services, things like SSM Systems Manager, which allows you to do things like desired state configuration. And if you wanted to manage server-based firewalls, you could use something like Puppet, you could use any of those sort of tools to deploy and keep these things in line.
Yeah.
So if somebody did manually change it, it would just change back
Yes,
the next
exactly.
time it ran. So
That's
there are options there. But again, the more layers you have, the more likely you're going to be able to protect yourself. So in this particular example, a good pattern could be on your database server, you'd have a knuckle just exposing the single database ports to the app tier. And that would actually mean that you don't have to rely on the operating system and its rather permissive port ranges. You can actually secure this, and the application team can't expose any ports because they have no control on the knuckles, and they themselves can look after the security groups. And security groups have a lovely feature where security groups can trust security groups. So there's no longer having to talk specific IP addresses. You can literally say security group A trusts security group B on this particular port. So any new servers they get, 100 servers could appear in that security group, the rules will automatically adjust to allow it. And you can tell a security group that it can trust itself, so it can allow all servers inside the same security group to talk to each other. So there's a lot of useful features that can be done there to make your automation easier for you. So we're going about the network access control list, about them being stateless. We'll send out the slide decks to you guys when this is done, because it's just handy to look through some of these. It's very important with NACLs to remember the limits. You can increase them, but that'll be at the detriment of throughput for your network, because you want to paint within these lines and you want to keep the rules very broad. If ever you find yourself doing point-to-point rules inside your NACLs, you'll probably be too specific, and you should just be more general with those particular rules. Yeah. No, you can go through them real quick if you get too creative. So again, as mentioned about private link, the various uses of it would be to be able to expose a service to another VPC. You could build that yourself. It's quite a straightforward process. You can get access to AWS services. So now, if you did not wish for your service to ever have internet access, your VPC can talk to everything it needs to talk to. Over 100 plus services, I think it's probably more now. You could take the IGW away from the internet gateway, away from that VPC, which means no traffic can come in. That has actually restricted your application to only being an internally operated one, which is quite a major change. And again, SaaS operators can advertise directly. So in the old days, if they needed to get really secure, they would offer a VPN to you, and you'd have to build up networking for them. But this way, they can actually advertise or offer a private link connection to you, which is pub-sub type approach, where you would accept this connection to their private link, and it would appear in your network as if you're talking to them locally. It means that nothing goes across the internet, and it's a very secure connection for being able to talk between AWS infrastructure. And then, of course, your direct connect and your site-to-site VPN clients can also use these private links by just channeling to them and doing the same sort of DNS masquerading that happens. And another one that this one is, for whatever reason, has never been published really well. We introduced our own hypervisor called the Nitro system. So it's getting saturation as being obviously the hypervisor of choice, because it's really secure, really efficient at what it does, and people can't log into it. Whereas most hypervisors is like the god mode for the entire virtualization stack. With the Nitro system, it is built really secure and prevents people being able to log into it, even from the Amazon side of things, and what keeps everything separate. The reason I brought it into this is Nitro to Nitro communication is encrypted on the wire. So the problem with encryption is it's very CPU intensive. So if you try to build an encryption in transit for something like a container cluster, you'd be paying the price for that in CPU cycles, because you'd have to encrypt, decrypt, and do all this sort of stuff. If you then use Nitro-based hardware, you don't manage the keys yourself, the AWS managed keys, but it is encrypted on the wire, so it is in fact you getting that encryption for free, not paying CPU cycles to do that. So next time you have that sort of local in-transit encryption between services as a requirement, the Nitro hypervisor can actually solve a lot of those problems for you without any additional costs being put into it and additional stuff. Any questions about the local VPCs there?
Is Nitro ISO compliant?
Yes, the Nitro system, if you go into artifacts.aws.com, you can actually have a look and see which it's ISO 27001. It'll have PCI compliance because they brought out ISO enclaves, which means that you can actually keep services running encrypted in memory. So if you go into the compliance, you can see because they change regularly and are different country to country. So there's a lot of compliance work done on these things, but the Nitro system was sort of vetted for a lot of them. Right, internet working. How do you connect all of your VPCs together? In the early days, we introduced peering, which meant you could pretty much just peer two VPCs together, and you could build a hub and spoke type thing. There were non-transitive connections, which means you couldn't bounce via another VPC onwards. The problem is it did not scale very well. It was okay when you hit up to maybe 20, 30 VPCs, but when you go full mesh, every time you add another one, it exponentially increases the connections, and they become difficult to manage. So we introduced the transit gateway. Now, don't get me wrong, peering is still something you should consider for point-to-point type communications because it is essentially free. Where transit gateway, you do pay connectivity and data transfer charges for using the transit gateway. It is often cheaper to use peering, but if you are talking about something that needs to go to scale, then the transit gateway makes administration a lot easier by interconnecting the VPCs through, if you like, a transit network. So, as soon as you talk about global connectivity, and if your network becomes that complicated, it's difficult for you to trace any faults that occur, then you should start thinking about the transit gateway because it has a management plane and it does end-to-end tracing that makes life a lot easier for network administrators.
So is it like auto full mesh, or what does it do, or do you still say like this guy to talk to?
So I'll skip on to just one of the pictures. We'll run through because it'll be easier if I'll show you a full mesh on how it works. Again, key features on this is centralized routing, peer transit gateways together across regions so that you can connect multiple different locations together. It can do multicast traffic, which is something we didn't natively support up until now. You can do thousands of VPCs and increase connectivity with multiple VPN connections. One of the major differences here is you have to connect all your VPNs to every single VPC or to a central VPC like shared services in the middle of your hub so they could jump the one hop across to the other ones. But now you can connect all the VPNs straight to the transit gateway, which means that it becomes a lot simpler for you to be able to manage. And you have bespoke control as to what routes get advertised to those VPNs. So it makes it more enterprise scale network compatible. And again, flexible segmentation, routing rules, horizontally scalable, and simplified management and network visibility. And some key benefits to that, but I'll get on to the way you connect things together. So over here you have, let's just say 3 VPCs, but the truth is this could be 1,000 VPCs in each stack if you wanted to, if production was to that scale. And the idea of a shared services, so the concept of shared services, it would be that center point network where you keep things like your Active Directory. You keep stuff that doesn't belong to the application, but everybody gets to use it. So shared services is often a key. It's the center of your hub and spoke type methodology. So again, cross-account roles. I'm not sure why that's in this particular slide, because that's what I'm talking about. So what you end up doing is you build a transit gateway, and you effectively build network connections into each VPC. And like the private link, they look very similar. They'll have a local address inside each VPC, and they'll appear in the routing table. So you could say 000, you need to talk to anything, you go out to the transit gateway and it'll sort it out. So the local VPC routes would just say, my gateway of last resort is the transit gateway. And if you're not one of my routes that I can deal with, you bugger off to the transit gateway and it will look after it and deal with it. So it becomes a lot simpler on the VPC, and you can get quite creative with this sort of stuff. So I think you can do about 15 different routing tables out here that like shared services could have. You could have egress networking. You can get very complicated with it. So again, there's the routing tables. In this case, they're just demonstrating 2, but you can go up to 15 of them. And then you can have a prod routing table, a non-prod routing table, and a development routing table if you wanted to, and then shared services which can route to any one of these. And that way you can actually segregate east-west. So development couldn't talk to prod because there just aren't any routes for it. You can also introduce something called a black hole route, which beforehand in VPCs you could only do accidentally. But what you could do now is you can literally, to prove compliance, you could put a black hole route in for production networks from development and say, if I ever receive a route for this network, it goes in the bin. And if there was no route, it still wouldn't be able to get there, but it's easier with an explicit deny, if you like, to be able to prove it for the sake of compliance that this route cannot be done. Because again, with the network rule is if you can't reach it, you can't hack it, so or you can't break it, in fact. So what I mentioned earlier is your VPNs now can connect to the transit gateway. Now, one of the important things that VPNs now support is something called EGMP. So let's just say it's a 1.5 gig limit on each VPN, but if you needed to extend that, you could put 5, 10, 15. I've seen it go up to about 50 VPN connections, and then spread the load across all of them. And what the transit gateway, you could do that before to a certain degree, but return traffic could only use one particular link, so it was very imbalanced. But now it can actually do all of that, and you can actually do the VPNs. We have introduced MAC level encryption on Direct Connect. So what a common pattern used to be, you have a Direct Connect and you put VPNs across it, especially if you're going over a service provider, because it's all in the clear and it's going through their data center. So people would be rather worried about putting their sensitive data across a third party and not being encrypted. So you get by a Direct Connect and then do a whole heap of VPNs across it. We've worked around that, and it becomes a bit easier now. The next pattern that becomes quite important is something called centralized egress. So now imagine in all these VPCs you're putting out there is no internet gateway anymore. Literally, if they want to communicate anywhere, the application team has no control. They cannot build an internet gateway because you've blocked it, and they can't accidentally advertise something that they shouldn't do, which is a big concern for folks, especially in this security. So what you do here is you say the path to the internet has to go via the transit gateway. Transit gateway knows the path to the internet is via a specific VPC that you built, and it's just a normal VPC. For outbound purposes, and in this you can have a proxy server, and then that proxy server can be used, or you could have a whole heap of security appliances that you might want, a NAT gateway, all this kind of good stuff, and that means that you're actually only running 3 NAT gateways instead of 1 for every single VPC that you have out there, and it means it's more central control. Two-edged swords, that means you can always break it in one place as well, and you have to take that into consideration. But for the most part, it is easier to manage in a single place. And if you have to do inline inspection of traffic, you've got a single place to do it. You don't have to roll that configuration out across all the VPCs. Yeah, go for it.
If you have multiple organizations, let's say dev is on a separate org, production is on a separate org, do you have to set up a transit gateway on its org?
No, so you can, the transit gateway uses something in the back end called Resource Access Manager, RAM. You might have heard the term RAM shares, which means you can actually advertise the transit gateway out to another org if you wanted to, and that way you can connect it through.
But your central configuration will be on...
Still the primary organization that controls the network gateway. The only thing that the other organization will see, they will see the transit gateway, and they can throw a connection across to it. They can't modify the routing because that still has to be done on this side of the connectivity that you go with. So yes, no, it is quite supportable. You could also peer 2 transit gateways together, but for the most part you could just share it between organizations, and that should fix the problem that you're trying to do, or directly to another account.
Yeah.
Share it to your entire org, and then, or a particular OU inside your org. So if you had prod as an OU structure inside your org, you could just share this transit gateway just to prod if you wanted to. Or another account if you knew it by name. You could do this whole publish and subscribe type model for that. Now, the same thing happens with internet ingress. A lot of companies want to be able to control their WAFs, their content delivery networks, ingress VPNs, but they want to do it in a centralized fashion, because that means that if I publish a new server side here in production, somebody would have to come and actually do the configuration, and you could be using our WAFs, or you could be using third parties. You could be using Cloudflare, any of this kind of good stuff, but you want to configure it in a centralized fashion so that as soon as the traffic ends up here, it does a reverse proxy and is able to hit the production service over there. So prod deployment, for example, would then take 2 stages. A new service would be stood up in production, and then the networking team would then start using the load balancers configured here to do sort of A/B deployment or spread some of the load to a new one, but it can be centrally controlled. And that means that it does take some power away from the individual application developer, but it also sets up some guardrails. And I think a lot of people, if it is not their speciality, networking, can actually just keep changing configs until it works, and then not realize that they may be exposing something that they have not exposed. And plus, you can also do traffic interception here, and do data loss prevention and all this kind of stuff if it is important.
So all this architecture is for the transit gateway.
Correct.
And so let's say that we're talking about like normal peering. So can we still have this like the outbound and inbound services? Or?
You would have to then build it, because remember you couldn't hop through multiple VPCs, so itself would have to be part of the hub inside your network.
Right.
And then your proxy server, for example, you could build it inside and do something similar with peering. The only problem is that past a certain, like anytime you're going to look at more than 20 VPCs, it's going to start getting complex peering back and forth, and that itself can just not be worth the effort. But it's worth weighing up the cost between the two, and often if that is a better suited option to you.
No, but I think what you're saying is right. It's like 20, above 20 VPCs going to be.
Yeah, it becomes a problem, because as soon as something gets too complicated and you're deploying this code, there's a chance that you can easily break it while trying to add a new piece into it, and then it all comes crashing down. Whereas this just makes it a lot simpler and less overhead to maintain.
Is transit gateway a regional resource? So is it per region?
Correct.
So
It's per region. You can build in one in another region, and you can connect the two together. You can do what they call a TTW peering connection to another region, which means itself will just appear as if it was another incoming connection to that router, and you could plug it into whatever routing table you saw, so you can limit what it could see in another region, or you could just go hell for leather and let it see everything that the other ones can do. So you've got quite a bit of... the other nice thing about Transit Gateway is there's Transit Gateway Manager, which allows you to do end-to-end tracing. So you could pick an IP address in this particular VPC over here, you could pick an IP address in that particular VPC over there, and you could say, tell me the route. And it can hop between regions, and it'll give you a nice trace route from end to end, which is really awesome when it comes to trying to figure out where something has gone wrong, because it'll tell you exactly which routing table is missing a return route and this kind of stuff. And because we didn't support ICMP TTL to lives, you can't use traceroute or any of that sort of stuff to navigate this. So it became a stare and compare competition until they actually built this functionality, and it sort of pays for itself. It's a free service that comes with Transit Gateway. Cool. And then what the other options it gives you is things like what they call east-west inspection. That means if, for example, this VPC decided to talk to that VPC, you could change the routing so that it goes through an inspection VPC that, again, would offload the packets and do threat analysis on all the packets going through. Again, you need to have a very specific use case to make this necessary, because it is expensive. You're hauling data back and forth, and often the appliances that sit in there are not cheap. So if you have a regulatory compliance reason to actually do this, it is now supported and can be done quite easy. Otherwise, you would get quite complicated in the past to try and implement this. And the biggest thing that was complex was the ability to maintain these firewalls, because you'd have to build some sort of auto-scaling group out there and make sure that session is maintained, because it's pointless having 2 inspection nodes, and then every second packet is bouncing between the two, and you then have to stitch all that together. But we introduced something called the Gateway Load Balancer, which made that concept a lot easier to be able to manage and service these firewalls. Yes, the last note. Private link, because you're paying for every private link connectivity, there's a lease rate on it. When you start using Transit Gateway, a common pattern that folks do is then put all the private link stuff, with the exception of a few of them, into the shared service. And when I say by the exception of a few of them, there's a few private links that are AZ sensitive, things like the EFS private link, which means it's always going to use the private link connectivity in the local AZ to service servers in that same AZ. Now you would lose some of that functionality going across, and the latency would probably make that sort of file transfer not worth it. But the majority of all the endpoints can be centralized in a central account, and then you only pay for a single entity of them, and you just haul the data across. So often in the egress network, people will also put all the endpoints in there. They don't go out to the internet. It just means that as they're heading for the internet, they can take a left turn over there and be able to build. Cool. Any questions about internet working within AWS? Sweet.
Pricing for transit gateway within your own accounts. So if you were doing what you said there about moving the endpoints to shared services, what sort of is the pricing on per gig that gets processed by the transit gateway as well?
It is. The pricing scale is by every network interface that the transit gateway puts down. There's a lease rate on that. I can't remember what the pricing is at this whole point, but if you type in transit gateway pricing, and then it's per gigabyte pushed across it. So it's worth weighing up the costs and seeing where data transfer costs is always something that should be considered with any of these network architectures, because it can get pricey if it's not considered properly. But the pricing calculators that they brought out are pretty good at figuring out exactly what the end-to-end costs would be. Cool. The network perimeter. We start off with a few new service that came out called the AWS Network Firewall. Then we'll go into WAF, Shield, which everybody gets standard Shield DDoS protection, and then Shield Advanced, and what the difference between those would actually be. And then AWS Firewall Manager, not to be confused with the Network Firewall, which fixed a problem that folks had with deploying firewall configurations, managing a security group, any of this sort of stuff at scale. So I'll pick them apart there. And the common edge type security risks are going to be things like denial of service, app vulnerabilities, and bad bots, which can cost people a lot of data transfer costs every year. So I'll start off right at the top with the Firewall Manager. So what this is it's a service, a regional service that allows you to look at all the security groups in your organization and assess them for compatibility to whatever rules you had. If they're overly permissive, you can tell Firewall Manager to detect the rules, any configurations you don't like, and auto-remediate them. So you can now put the security groups in the hands of the application developers, but still retain an oversight across all the security groups across your platform, and be able to remediate these things, or just warn when you see them, and then go hit somebody with a chair when they make something bad happen. Now the same thing happened with AWS WAF. So if you have not got a centralized sort of ingress pattern, should I say, and you're deploying multiple WAFs in multiple VPCs, you run into the same problem. You need to be able to deploy WAF rules across all your environments. Now, because the WAF is handling all your incoming traffic, if you deployed bad rule set to, say, for example, your production service, you're actually going to take yourself offline. That happens. So you'll start looking at the same features that you'll have a non-prod WAF and you'll have an end-to-end testing WAF, and you need to be able to orchestrate these rule sets as they are deployed between them. And then again, Firewall Manager helps you with that, because you can see what the status of each of the rule sets is across the organization. So anytime you're doing any of this networking stuff at scale, the Firewall Manager offers you that visibility. So there's two major ways to do it. Either you centralize your ingress and egress, or you distribute it and allow multiple, or a combination of the above if you have multiple organizations that have been joined together. Either way, Firewall Manager makes this job a lot easier for checking the status of your network. Next, it will also, if you had any Shield Advanced, you'd also be able to manage it through, and I'll get onto that in a bit, and any configurations for the Network Firewall Manager. It allows you to manage them at scale. I didn't realize there's animations on this one. Okay. And again, the auditing capability that I spoke of, and this was its initial service that the Firewall Manager offered, was being able to, and this was asked for quite some time, to be able to audit all these security groups and allow them to be centrally monitored.
Can't you use config?
You can, but you'd have to write config rules and you'd have to write remediations for it. And Yeah, you certainly, I mean, Firewall Manager does actually use config in the background, and it uses that as its detection engine, but it comes out with a lot of out-the-box stuff that you don't have to write yourself. So in a way, you could definitely build this. You could even do a lot of this stuff with tools like Puppet or Chef if you wanted to. But the problem is it's that it takes a lot of maintenance to do that, and if it's not the core business of your company, then it may not be making you guys any money to do all that sort of stuff, where it's often easier just to purchase a service that does it and then not have to worry about maintaining it, or when the underlying security group has a fundamental change that you need to deal with. So, and that's exactly how people used to do it, build all this sort of stuff themselves. And I think they just got tired of maintaining it for so long. The network firewall, so it's a long-awaited feature. I'll talk about the shared responsibility. So in the past, folks would roll out their own firewalls, and we brought out the gateway load balancer to make that a little bit easier to manage your own firewalls. But the problem with it is always going to be managing scale and managing availability and all this kind of stuff. It's a lot of effort, and it takes a dedicated network team at any sort of scale to maintain this stuff, because the worst kind of outage is one that you sort of cause yourself with your security appliances taking you offline. So we take away a bit of the heavy lifting. So what the end user does is they create firewall policies and rules, they deploy and route traffic to the endpoint, and then they can centrally control all the firewalls with Firewall Manager if they had more than one deployment of it. And what we're responsible for is the auto scaling, the throughput performance, and the session symmetry. As I mentioned before, when you're talking across VPCs and availability zones, it's very important that traffic stays within their own availability zones so that you can maintain a full session on the TCP side of stuff. And the resiliency and the SLAs around the firewalls is what we look after. So what it does, it is a device that allows stateless and stateful rules to be applied to it for incoming traffic. It is quite complicated. And again, we use stateful rules for broad strokes because they are really low effort to implement, whereas stateful rules take a bit more processing power. So you want to do all your broad stroke stuff as stateless and then pass it on to stateful rules to do the more specific stuff. We then go all the way layer 7, and we can do things like FQDN filtering. So you could say, I only want to allow you to talk to a whitelisted type DNS names that are out there. You can go all the way down into the entire path, HTTP path, and then say what people can talk to and what they can't talk to, and add variables on here.
Yes, sorry, how does that tie into the, like you previously said there's a network access list, which is that a service that like tied into the VPC, or, and this is
Yes.
like the firewall?
So no, the firewall is a complete appliance. So you know we said we centralized and we can inspect traffic. The firewall is an actual appliance that does both stateless and stateful. The NACL itself is tied to the subnet, and you can apply it to the subnet. So itself is basic stateless sort of inspection, whereas this allows for a lot more advanced. And if you have a use case for it, give an example. If you in your security group as well, if you said I want to be able to speak port 22 to a public address. Now, it would take it as far as the TCP to determine that it's in fact on port 22, and it is TCP, that's fine. Whereas the power of like the network firewall will be able to tell you the version of SSH has been spoken across that connectivity, and you can say only V2 is allowed to make the connection out. And you have a lot more application level rules that you can actually get. So you can get very complex with these Suricata rules to be able to build complex network patterns. But again, it is something that if you have a use case for it, they can get a lot more complex, and there's a lot of complexity that can be baked into that. So, but it does make life a lot easier if you've already got firewalls in play and you have to maintain these. That means you can take a lot of those configurations, and we have a lot of third-party subscriptions. So you can, from Checkpoint, for example, they can interact with these firewalls and deploy their managed rule sets onto them. So you can then just remove a bit of the heavy lifting of maintaining these firewalls and virtual appliances. Visibility and reporting integrates with CloudWatch metrics, full flow logs, you can create events. So, for example, if you notice somebody was talking SSH v1, you don't necessarily block it, but you can alert on that fact, and